All right, we're going to be working on lesson 7.4, and what we're going to be looking at today is the division properties, okay? So let's kind of jump right in here, dividing powers with the same base. So if you kind of look here, see how we've got a 2 base and a 2 base, x's and x's, a's and a's. So as long as the base is the same, then we're going to subtract the exponents, okay? Let's go ahead and jump right in here on the first one. So when we're looking at something like this, we're just going to subtract the exponents, leave the base the same. So we're going to leave the 2, and then what we're going to do is we're going to take 6 minus 2 and get 4. So when we're dividing, we're going to subtract. Now, I still expect you to go ahead and come up with that 2 times 2 times 2 times 2 is 16. Okay? All right, let's look at the next one. So now when we've got a variable involved, it's the exact same thing, okay? Leave the base, so it's going to be x. And then in this case, it's 4 minus 7. So if I look here, 4 minus 7, that's going to give me x to the negative 3. Well, that doesn't work so well. We know that we can't have a negative exponent. So we have learned back from 7.1 that that would be 1 over x to the third. All right, and next one here. Okay, we're still doing subtraction, but now we're going to be dealing with fractions. So base stays the same, so leave it as an a. And then you're going to have 3/4 minus a half. Okay, keep in mind that technically you do need a common denominator, so we would have to multiply this guy by 2 and get 2/4. Some of you will be able to do this just right in your head, 3/4 minus a half. Some of you will need to do the common denominator and say 3/4 minus 2/4 is 1/4. Okay, so we end up with a to the 1/4 as our final answer here. All right, so let's go jump down here and look at the first example. Okay, so again, we're going to subtract, leave the base the same, so we've got y, and we're going to take 7/2 minus 3. Now go ahead and put that 3 over 1, and let's come up with a common denominator, which would be 2. So I have 7/2 minus 6/2. So 7/2 minus 6/2 is 1/2. So I'm going to have y to the 1/2 as my answer. All right, so now in the next example here, now we're going to look at what happens when we have multiple letters involved. So just keep in mind, the K's are going to line up with the K's, and the J's are going to line up with J's, okay? So on the first one here, K, so if I keep in mind here, I've got a 1 right there. So I'm going to have K to the 5th, 6 minus 1, 5. And then I'm going to subtract the J's, and when I take 2 minus 5 here, so 2 minus 5, that's going to give me a negative 3. Okay, so a negative 3. So now when I'm thinking about that, reminder, we can't have this negative exponent here. So we're going to have K to the 5th up on top, and J to the 3rd will move to the bottom, and it becomes positive when that happens. And that's going to be your final answer. Okay, so now when we're looking at this one's a little bit different. A lot of times what kiddos will do is they'll say, all right, well, we're going to subtract, and they're right. This is one way to do it. We're going to subtract, and we're going to say negative 3 minus 5, and that will give me a to the negative 8th. Sometimes some people, though, get a little confused by that, and so another option here is to just think about, okay, if it's negative, where does it have to go? It has to go down here on the bottom. And so now I have 3 A's on the bottom and 5 A's on the bottom. When they're side by side, that's going to give me 8 A's on the bottom. It's the same thing as what this guy is saying with the negative 8, right? The negative 8 means I would have to put a 1 on top and the 8 would drop. So I really don't care if you think about just moving this guy down, making it positive and adding, or if you want to think about it again as subtraction right here and do negative 3 minus 5 and get the negative 8 that way. It doesn't matter, okay? And then we're going to look at the B's, and this is kind of easy. So we subtract and we get 5. 7 minus 2 is 5. So B to the 5th will stay up on top because it's positive, and that's going to be your answer. All right, next one here. Now, I keep saying it over and over. I am not teaching you about the 3 and 15 out front. I'm only teaching you about all these little guys, okay? So the 3 and 15 out front, that does not change. We're going to go ahead and call that 1/5. So just reduce your fraction to 1/5, okay? Now in this case, I've got x to the 4th and x to the 4th. Well, when I take 4 minus 4, I get 0. We know that x to the 0 power would just be 1. Or just think of it as, guys, they cross out. They cancel each other out. So there's no more x's. All right, and now on the y's, okay, again, you have two ways to think about it. You can go ahead and move, so you can move this down and move that up, so y to the 5th on top and y to the 1st on the bottom, and then you can subtract and say I have 4 y's left on top. Your other option is to actually just subtract these two guys and say -1 minus -5. Well, that becomes plus, so I end up with a 4. And notice how I've got y to the 4th up on top. If it's positive, it stays up on top. Okay? And then this one, again, is kind of easy. It's just 8 minus, remember there's a 1 here, so 8 minus 1 is 7. So then z to the 7th up on top. And that's going to be your final answer. Okay, let's go down to the kind of the next topic here, and that is what happens when we now have a fraction on the inside as a base. So all my bases are now fractions, and what do I do there? Okay, so to raise a quotient to a power, raise the numerator and the denominator, so top and bottom, okay, to the power and then simplify it. All right, so what this is saying is that we are going to basically, kind of like we talked about distributing the 3n. So remember, we both have 1s. So I'm going to distribute the 3n to both the exponents. So this will be 3 to the 3rd and 5 to the 3rd. Okay. Now, again, I still expect you to reduce your fraction or simplify. So 3 to the 3rd, 3 times 3 times 3 is 27. And then 5 times 5 times 5 is 125. And there we go. Okay, so now it'll be the same thing here, right? These both have an exponent of 1. We're going to drop this into both parts, so we get x to the 5th and y to the 5th. Nothing I can do there, so that's my answer. Okay, and it's going to be the same thing here. You're going to we have 1s on both of those, so we're going to drop it into both parts. So we're going to end up with a to the 1/2 and b to the 1/2. And I can't clean that up, so that's my answer. All right, so now let's kind of dive in and take a look at problems that are a little more complex, okay? So keep in mind here, right, everything has an exponent of 1, and you're going to distribute that 3 into both little guys. So on the top, I've got z. The 3's would technically cancel out, so I'd have z squared. And on the bottom, I've got 5. 1 times 3, right? 1 times the 3 is 3. So again, I do expect you to clean that up, and that's going to become z squared over 125. All right, example B here. Okay, so there's a 1 here. We're going to drop that 3 into both parts. So I'm going to have 4 to the 3rd. In this case, again, multiply. So 3 times 3 would be 9, so x to the 9th. And then, as always, 4 times 4 times 4 would be 64, x to the 9th. And that's your answer. Okay, next example. All right, drop the 4 into both parts again. So I'm going to have a on top, a on bottom. Okay, and the bottom, 4 times 5 is 20. Now up here on top, if I put that over 1, remember these guys are going to cross cancel, so I'm left with a 3. Now, when we have something like this where we've got a on top and bottom, you still need to go ahead and reduce and kind of clean it up. Okay, so this is where we start applying what we just talked about, which is a subtraction. So when I look at this and I subtract, I get 17 a's left on bottom because I have more left down on the bottom here. So I have more left on bottom. Again, you can think of it as 3 minus 20, which would give you negative 17. And so if I have a to the negative 17th, that had better drop down, okay? Or you can just look, I got more down here on bottom, so my leftovers are going to be down here on the bottom. If nothing is left up on top, go ahead and put a 1 up there. So it's going to be 1 over a to the 17th. All right, let's go over and flip over to the next page. All right, and we've got 2 more examples here. We're going to look at, real quickly, what happens when we distribute a negative 3 into it. Distributing is wrong. But when we drop this negative 3 into the problem. Now make sure that you are dropping into all parts, including that 2. So negative 3 goes there, goes to the 6, and goes to the 4. Okay? So right now I've got 2 to the negative 3, x to the negative 18, and y to the negative 12. Now keep in mind, we can't have any negative exponents. So this guy, and this guy are all problems, okay? So we're going to end up moving everything. We're going to put y to the 12th up on top. We're going to put 2 to the 3rd on the bottom and x to the 18th on bottom. So basically, guys, I just kind of flip-flopped. The negatives moved down here. This negative moved up, okay? So now the last thing I've got that I can clean up right here is just 2 to the 3rd. Oh, sorry. So 2 to the 3rd will be y to the 12th on top, and then 8x to the 18th on bottom. And that's going to be your final answer. Okay, all right, so now let's try this guy. So we're going to put the negative 2 in, again, to all 4 positions, anything with a base. Okay, so I've got a to the negative 2, b to the negative 6, 5 to the negative 2, and b to the negative 2. Now, once again, since these are all negatives, we're just going to flip-flop. The bottom's going to move up, and the top is going to move down. Okay, so when I do that, I've got 5 squared, b squared moved up, a squared, and b to the 6th moved down. Okay, now we do have to clean it up. So 5 squared is 25. Okay, a squared is just going to stay there. There's no other a's. Now, again, look at this guy. We're going to subtract. So we get 4, and then where did we have more b's at? We had more on the bottom, so it's going to end up being b to the 4th. Okay, again, you can do 2 minus 6 and find out that it's negative 4. So b to the negative 4 means it has to drop, so you would have to drop that down. Okay, and there's nothing else I can do to this, so this would be my final answer. All right, that concludes the notes for lesson 7-4.